Now here we'll take a daily life example. When we throw the object in the downward direction, what happens to it? So this observation was given by Galileo. Okay, if I'm releasing the ball from certain height, so what do we observe? That in each second the speed gained by the ball is 9.8. Right, like suppose the moment I just release that ball, the initial speed will be 0, right? And if I look for the speed after 1 second, I'll get it as 9.8 meter per second. Then for the next second, I'll get it as 9.8 plus 9.8, that means 19.6 meter per second. Then in the third second, that will be 19.6 plus 9.8, that means 29.4 meter per second, and so on. That means here Galileo has observed that when the object is free fall under gravity, so here we get the change in the velocity per second as 9.8. So here we call it as acceleration, and the value of that acceleration is constant, which is 9.8 meter per second square. Right, so this acceleration we are getting because of gravity, and that's why we are calling it as acceleration due to gravity. So here if we plot a graph of speed versus time, if I have some values like after 1 second I'm getting the speed as 9.8, 2 second 19.6, 3 second 29.4, and so on. You see the constant difference is there, which is 9.8, 9.8, and so on. Right, so here speed is getting changed uniformly within a second. That means we can say that speed is changing at constant rate per unit time. Correct. So in that case we say that that is the case of uniform acceleration, and if it is the acceleration under gravity or due to gravity, then it has the value of, we also represent this as a letter G, 9.8 meter per second square. Now is it the case same, like we get the same value of acceleration 9.8 meter per second square if we have two different objects of different masses? Like if I take the light object and if I take the heavy object, then still will I get the value same? So the answer is yes. Acceleration due to gravity is same for all objects respective of the masses. That means if you are releasing those two objects from the same height, they will hit the ground at the same time, because they will have the change in their speed with the same amount within per second, which is by 9.8, as acceleration due to gravity is independent of the masses of the object. Then in Newton's second law, we have seen that the force acting on a falling object is given by, that means if I have two masses, one is lesser mass and one is greater mass, right? If I want to pull this smaller mass, I need to apply the smaller force. But if I need to pull this greater mass, I need to apply the greater force. Correct. That means according to the mass, force will change, but here the acceleration will be constant. So here we can say that force is directly proportional to mass. So if force is directly proportional to mass, and here we are talking about the force which is exerted by the earth on an object, then in that case what will be the constant of proportionality? So we must say that constant of proportionality is acceleration due to gravity, as we have seen that it is constant for all masses, of which the value is 9.8 meter per second square. So yes, here we have concluded that all masses have same acceleration. So more mass means more force needed. Then according to Newton's third law, every action has an equal and opposite reaction. So if I say that the earth is pulling ball towards itself, then earth should also be pulled by ball towards itself, correct? But here we see that earth is not moving towards the ball, it is at rest, it doesn't accelerate. So what's the reason? So here the reason is earth is a huge mass and it needs a very large force to make it accelerated, correct? And here in that case, when I say action reaction forces are there or action reaction pair is there, they have the same magnitude. That means if I say force on ball due to earth is equal to force on earth due to ball, because these are action reaction pairs. So ball is very small, right, in mass, so that force is enough to accelerate the ball, correct? But that same force is not enough to accelerate the earth, as earth has huge mass.